Alright, Introduction to Artificial Intelligence. Mark Toussaint, February 4, 2009. Major slides of search of CSP with the logic adopted by the Stuart Russell, the direct concentration reformation, all lecture slides exercise from Artificial Intelligence Course Winter Term 2018-19 UI Stuttgart, including an index helping to prepare for exam. Double start section slides are not relevant for the exam. Contents introduction to search, motivation and outline, problem fundamental examples, basic tree search algorithms, wildcard searches, probabilities, basic definitions, probability distributions, distribution over continuous domain, Monte Carlo methods, bandit MCTSs in games, motivation and outline, bandits, upper confidence bounds, Monte Carlo tree search, Monte Carlo tree search applied, POMDPS, game playing beyond bandits, active learning, 5, dynamic programming, the Markov decision process, dynamic programming and belief space, reinforcement learning, motivation outline learn, motivation Markov decision process exploration, policy search, imitation inverse RL, other mounts, interactive domains, basic taxonomy of the domain, models, constraint, satisfaction, problems, formulation, example of methods of solving constraint, satisfaction problems, constraint, satisfaction problems, graphic models, Bayes nets, conditional independence, interference, reference models, graphical models, dynamic models, AI, machine learning, neural nets, explainable AI, propositional logic, syntax, semantics, interference methods, first order logic language, first order logic inferences, relational probabilistic modeling and learning, exercises 1 through 7, index, introduction. What is intelligence? Maybe easier to first ask what seems we actually talk about the decision making, interacting with an environment, define objects, then define objectives. Quantify what you consider good or successful. Intelligence means to be optimized. Intelligence as optimization. A cognitive science psychologist. Why are you AI people always so obsessed with optimization? Humans are not optimal. They're the total misunderstanding of what is being optimal means. Optimization principles are mean with the described systems of Feynman's unworldliness, measure, objective, function. Everything can cast optimal under some objective. The optimal principles are just scientific means formally describing systems and their behaviors, like physics, economy, and AI. Trueslant Ritter book organization wrote Route to Robotics and Alternatives. That's by Conscient Intelligence, German guy, I guess. Generally, I would roughly distinguish 3 basic types of problems: optimization, logical, categorical inference, or constant stereo processing, feasible solution, probabilistic interferences. What are interesting objectives? Learn to control all the degrees of freedom of the environment with controllable. The DOFs are mechanical kinematics of DOF's object, light and temperature, mood of human. The objective of generics, non-preference, non-limits, implies actively exploring, finding controllable DOFs. Acting to learn instead of learning to act. Acting to learn instead of learning to act for a fixed task. Related notions in the other fields: experimental design, active learning, curiosity, intrinsic motivation, At time t, the system will be given the random task, random goal configuration of the DOF. The objective then is to reach it as quickly as possible. More on objective value, alignment, and dilemma. What objective is described with the creativity, empathy, etc. Coming with objective functions imply desired behavior and core part AI research. Interactive domains show the agent with going to the action environment, the perception, and the word going back to the agent. We assume the agent is interaction, which domain the word and state is word is in state. See below what it means. The agent senses the observation. The agent decides on an action. The world transition to a new state. Observation describes all information received by the agent. Sensors all of the word's feedbacks, if not explicitly stated otherwise. The notion of state is often used precisely at any time. We should use the world as in a state. A state or state description of the domain is a future observation or T or condition independently with all historic observations less than given state description and future action. Shows the agent, and then it aligns with several different future actions and history observations. No, intuitively, the state description describes everything about the world. Relevant worlds do not have additional Latin hidden variables to the state description. Examples: what is the sufficient definition of state of a computer that interact with? What is the sufficient definition of thermostat scenario? First, assume that the room is an isolated chamber. What is the sufficient definition of state of the autonomous car case? In real worlds, the exact state of practical but not representable. All models of the domain will have the maximum approaching assumptions about independencies. How can agents be formally described? A formal class of agents do exist, but basic alternative agent models of the agent maps, stimulus response mapping on optional agent stores all previous observation maps. The agent F is called the agent function. Most generally, model include the others special cases. Agent stores only recent history and maps. Crude may be good heuristic. The agent of the machine within its own internal state of the computer, finite state, machine, and brain. The agent maps internal state updated to agent maintains full probability distribution belief over the state of maps and the Bayesian belief update. The POMPD coupled to the state machine agent. Agent shows agent maps number 1, 0, 1, and 2 with so multiple agent domains, technical term of the decentralization POMPDs. Special type of simplification general of the DEC POMPD. Generally level the description general the next par hard approximate methods can be very good result through summary AI. The system that interacts with the environment. We distinguish system and environment, or CF the embodiment, which introduces basic model interaction, core part of AI research development, formal modes of interaction. System aim to manipulate environmental towards desired states of optimally principled standard way to describe the desired behaviors. We sketch some interesting objectives. Coming up with the objective functions implied with the desired behavior core part of AI research organization involves learning the MLRB. There's a bachelor's grant and master's, such as infinite systems, math for intelligent system, introduction, robotics, machine learning, optimization, reinforced learning, advanced robotics, practical human course robotics, and machine learning robotics. Computer Andrews, Bertrand, and then it keeps going through these different authors. Two, search, motivation, and outline. Search algorithms are a core tool for decision making, especially with the domain with the too complex with the alternative with the dynamic programming. Increase the computational power search methods became the standard method of choice for complex domains, like game of Go, certain POMPDs, POMDPs recently. They are combined with a machine learning method of the heuristic evaluation function guided research learning about search tree algorithms. Important background, several reasons for the concept of the decision, the representative space possible through the decision, same state transition. Generally important thinking about the decision problem, probabilistic domains, tree search algorithms, special case for the Monte Carlo method to estimate some of the exemption, typically so-called Q function. Respective Monte Carlo tree search algorithms are state of the art in many domains. Tree search is also background and back tracing, constant standards procedures, as well as forward backward searching logic domains. We'll cover the basic tree search method of breadth, depth, and iterative dependent, eventually a asterisk wildcard. Outline problem formulation example of basic search algorithm problem formulation example of Romania on a holiday. Romania currently Irad flight leaves tomorrow with the Birch has formulated the goal of being Birchus at in that formulated policy of the various cities, action driving between cities, find solution sequence of cities, minimize cost for the cost of function. Example of Romania ordinance or any rated, and then shows the map. Determine the fully observable search problem. Deterministically full observable search problem is divided in 4 items: initial state, successor function, goal states, and step cost functions assumed to be greater than 0. Travel distance, number of actions executed, path of cost, sum of the steps of the cost, the solution sequence, actions leading to the state to a goal. Optimal solution is minimal path cost. Example of the eight puzzles: start state, goal state. States integral location of tiles, ignore immediate position actions, move left back, blank left right up down, ignore jamming, etc. Goal test, goal set, given path cost, I1 per move. Optimization puzzle set, MP hard, basic tree search algorithm, tree search example, the RAD, and it's written in a different language. Tree search example, tree search examples. Implementation state. The node state is a representation, physical configuration. Node is a data structure with a consistency with a pair. Search tree includes parent, children, depth, of path cost. State does not have states do not have parents, children, depth, or path cost. The expand function creates a new nodes filling with various fields using successor function of the problem to create with the corresponding states. Implementation general tree search, functional tree search returns the solution, failure, fringe, insert, make mode, initial state, problem, fringe, loop 2, infringe, empty with a return failure node, remove front fringe. If goal test problem state with the node with the return node, fringe, insert all with expand with the node, problem, fringe, function, expand, node, problem, return set of nodes, successor with the empty set with the enters, the successor empty set, enter with each of the result with the successor with a function, problem, state, node 2, state, add a new node, parent node, enter action node, state node, result with a path cost, but it equals result with a path cost node with a path cost step code, the node interaction, result with the depth node plus 1, add successor, return successor. Search strategy. The strategy to find picking, ordering, or fringe strategy evaluated along following dimension completeness. Does it always find a solution that one exists? Timely complexity, the number of nodes generated, expand with the space complexity with the maximum number of nodes on the memory. Optimality. Does it always find the least cost solution? Time and space complexity, they're measured in terms of B, the maximum branching factor each search tree, with D, the depth of least cost solution, M, the max depth of space. May be infinite. Summary of the search strategies: bread burst, fringe of the FIFO, depth of the first of the fringe, and fringe LIFO, iterative, the depth of the search of the reach of the depth of the increase of the depth, limited uniform cost, sort of fringe of G, a wildcard sort as the F is equal to G plus H, sort of fringe uniform cost. Bread first charge, pick shallowest unexpanded node, implementation fringe of the fringe, Q, the new successor, end, A that goes to B, the B that goes to D to E, the C that goes to F to G, or A, B, C, and then you'd have C, and then it would go to D, E, and F. Probability of the bread first search completeness, yes, if the B is finite time. 1 plus B plus B, 2 plus B3 to BD to BD minus 1 equals 0 to BD minus 1. Expansion of D space of the O equals 0 plus B and the time. Sum of the distance plus 1 keeps every node in memory optimal. Yes, it's cost per step 1 non-optimal. Otherwise, space is a big problem. Can easily generate 100 megabytes a second, and so for 24 hours at 8,640 gigabytes. A uniform cost search, cost awareness BFS. Pick least over the cost expanded to know over the implementation fringe queue for the order of the pass cost lowest first equivalent bread first step cost equal to the complete yes step cost greater than E, the time of the nodes of G is less than greater than equal to cause the optimal solution, where C function is called for the optimal solution space of the number of the nodes of G the less than cost optimal solution. Optimal yes nodes expand with increasing order of Gn. Depth first search pick D, but the unexpand for the node implementation fringe for the LQ for the part successor on the front. It shows these different parts. Probably with the depth first search. Complete no fail with an infinite depth search for the space of the loops modified or void with the repeated steps states along with the path complete finite space with the time with the time O M B M with the tariff the M is much larger than D with the solution with the dense with the much faster with the bread first with the space. Questionable O B M and linear space with the optimal no depth limited distribute the depth first search with the depth limited with the nodes with the depth of the no success with the recursive implementation using stack LIFO function depth deep left limited search problem limit returns of the isolation fail with the cutoff of the recursive of the DLS make no of the initial state problem limited function with the reclusive of the DLS no of the problem limit return solve with the fail with the cutoff occurred and fail with the gold test problem state with the no of the return node else with the no of the equal with the left of them return over the cutoff else with the each of the successor is expand with the node of the problem due with the result of the reclusive of the DLS depth limited to search for the successor problem limited result of the cutoff curve with the result of that makes true with the true else with the result with not equal with the failure with the result with the result with the cutoff curve with the return cutoff else return failure. Iterative deepening search function, iterative deepening service or IDS problem returns as a solution inputs problem. The problem of the depth of the result is true if 0 to infinite due with the result with true with the depth limited true with the problem the depth if the result with not equal with the cutoff of the return result end. Iterative deepening searches limited to 1, limited to 2, limited to 3. Properties with iterative deep search complete. You have the time with the time distance equals 1. B equals 0 plus D B1 plus D minus 1 plus B to the second plus B to D equals 0 BD. Space of the OBD optimal. Yet step cost 1 can be modified exploring uniform cost numerical comparisons. B for the 10 and D to 5. The solution far to the left. Far left leave at the end of the iterative deepening search and the BFS iterative deepening search. This is better so with the nodes of the depth of the D with expand with the BFS search. BF searches apply goal test for the node generated. Supply without summary of algorithms. Bread depth first. Uniform cost depth first. Depth limited to interactive deepening completeness. Yes, and time space optimal. Alright, loops repeated state, failure to detect the repeated state with internal linear problem, the expectational one, ABCD, Google graph search, problem return solution failure with the close is equal as resulted from an empty set. The fringe is resulted from an insert make not initial state problem. Fringe loop did fringe is empty. The return failure the node is resultant from remove minus front fringe of the goal test of the problem state with the node with the return node. If the state with the node is not closed, then add state node to be closed. Fringe insert all expand the node problem in the fringe edge. Destroying all visited nodes leads again with the exemptional space complexity. Summary of the bread first uniform cost search fringe propagates layer wise containing node similar distance from star with the cost so far the leading optimal path with the expositional space complexity. The depth first search of the fringe of the depth of the deep light beaming sweeping over the tree with the space of the complexity with the relative of the deepening also leave the optimal path. The graph search of the exponential more efficient than the tree search by storing the vision of the exponential space of the complex with the breadth first search. The A wildcard search of the breadth first search, idea with the arbitration prior function with the node, with the actual with the function node with the negative polarity nodes with the lower frequency priority function with a higher priority. The priority function should reflect what the nodes can be with the optimal path. Could it is optimistic about the lower prior function with the more optimistic that you are with the node is on an optimal path. Pick the node the highest priority implementation fringe of the queue sorted with a decreasing priority, increasing the function value. Special keys uniform cost search, Grady search, and in a wildcard search function equals uniform cost search special case. Defined uniform cost search as to reach uniform cost search prioritized search of the function of gain. A search of the a search wildcard idea with a combination information past and future negative priority equals cost so far with the estimated cost to go with the evaluation of the cost function priority function equals uniform cost search special case equals estimated cost to go from cost so far to reach search and the node estimated cost HN equals cost to go from the node AFN estimated total cost to go from the node to goal. A search G with the minimizable equals optimistic heuristic equals the estimated cost to go from the node but it's greater than the is less than equal to the cost to go from the node where cost to go from the node, true cost to go from the node, also require the estimated cost to go from the node is greater than 0. So the HG is equal to 0. Any goal with the HLSD with the never SLD with the node with the never overestimates the actual road distance theorem and adds search with the finds the optimal path. Search example. Alright, proof of optimability with the A. Sometimes some optimability with the G2 with the generated with the fringe button has not been selected with the B test the good condition goal condition will want to prove the node on the short graph the optimal goal. G will be expressed with the G2. Let no unexpanded with the node the shortest possible path of G. Since functional primary function of the goal it will A2 will be to expand goal 2 with the tree with the node of the shortest path with a particular with the sum of the goal is added to the fringe since the function of the goal is equal to the gain of the goal equal to the function of the gain goal 2 equals goal 2 and select the goal for goal 2 for the goal setting testing. Priority of a complete yes unless infinitely many nodes with the function of the is less than equal to the function of the goal time exponentially with the relative of the error of the h length with the solo and space exemptional expectational keep all nodes in memory optimal yes. A expands all of the nodes within primary function of less than C, with the expand with the sum of the nodes with the primary function is equal to C, and expands no nodes when the function is greater. Primary function is greater than the C. Completeness. Optimal lemma with the expand with the nodes with the ordering and the interest of the function value with the gradually increase of the f function with the nodes breadth first add layer contour. I also knows function of the contour I with where function I is less than function n plus 1. Proof of lemma consistent heuristic consistence. If H is consistent, we have a set of logarithms and non-decreasing all any path immiscible heuristics. For 8 puzzle, the number of misplaced tile with the number of Manhattan dishes, the number of square with the desired location each of the tile. And then it shows the dominance for all of the bolts of the dominance of the H2 with the H1 is much searchable to typical searches, and it shows the different. This is basically how a better search. Typical search cost is basically your basic map and problems. Relaxed problem. Admissible heretics can be derived with the exact solution of the relaxed version of the problem. If the rule 8 puzzles are relaxed with the tile can move more anywhere with the heuristic node gives the short solution. If the rules relaxed with the tile can move it to any adjacent square of the heretics. 2 of the node gives the short solution. Keep half of the optimal solution cost of the relaxed problem is no greater than the optimal solution cost of the real problem. Memory bound, a wildcard, breadth first search, the wildcard exemptional space complexity, iterative, and deepening wildcard works for the iterative integral path cost of the problematic real overvalued, simplified memory bound wildcard, expand usual memory bound research. Therefore, whenever adding a node, remove the worst node from the tree with the worst means of the node with the highest function of the node to not lose information back up with the measured step cost of the cost of the node to improve the heuristic node of its parent. The SMA or the SMA compatibility optimal, depth optimal within memory bound. Summary: combine information past and future heuristic functions represent information about the tree's estimate cost to go optimistically. Good heretics dramatically reduce search costs. Search expand the lowest function of the gain over the heretics of the negative plurality cost so far over the estimated cost to go. The complete and optimal efficiency up to tie breaks and forward searches. Admissible heretics can be derived with exact solution. Relaxed problems with memory bound strategy exists. Outlook: tree searches of partial observations. We'll discuss fully probabilistic setting later. The tree search of the games of the minimax extension tree search probabilistic monocolor tree search methods of games. 3. Probability motivation outline. It's just needs to reason about when they know and not know, or the uncertainty may have the sum of any source of the environment may be static with the making impossible to predict future deterministically environmental can only be partially observed with the leading with the uncertainty of the mouth of the rest. The whole, especially with the environment that include with the order, agents, with the human intentions which are not directly observable. The system can only be collected limited data necessary leading to uncertain models of the calculus of the all probability for the right of the calculus of the trial Barrel's rule. But the principle tells us how we have to process the information, whether we've had prior uncertainty about something to get into the new information Barrel's rule. The terms of how to update with our knowledge of concepts over the general includes large part of the machine learning Bayesian, reinforcement learning Bayesian, filtering, Kalman, and particle filters with the etc. For the cavity course of the compute with approximately just for the basic information processing practices. In this lecture, they introduce some of the basic probabilities, many of which have learned before with the other courses, so they aim to recap the introduction of the notion with the introduced essential with the later lectures of the abandons for the reinforcement learning graphic modes, relation probabilistic models, outline the set of slides with the reference only with the asterisk with the ED below with the simplicity they discuss the lecture of the relevant of the exam of the basic definition of random variable joint conditional marginal distribution, Bayes theory, probability distribution by normal to beta with a multinominal direct conjugated prior of the Glazin-Wiscar standard diuretic and diuretic particle of the utilized decision theory, entropy, KLD, monocolor projection, important sampling, probability theory. Why do we need problems? Obviously, the extent to impress inherent objectives statically of the world, but beyond all the deterministic word, lack of the knowledge, hidden Latin variable expression, uncertainty expression, information, lack of the information, suspected probability theory, the information calculus, a probability double slit experiment. Thomas Bayes, 1702, with the 1761 essay toward solving the problem of the doctrine of the chances of the rest of the problem and inverse probabilities, knowing with the conditional probability of the B given the A with the conditional probability of A given the B. With example of the 40% of the Bavarian that speaks dialogue, only 1% of the non-Bavarian speak dialogue given the random of the Germans speak with the non-dialogue of Bavarian, 15% of the Germans are Bavarian. Inferences equal give some of the piece of the information privacy over the variables with the implication information the posterior on the non-observed variable. Decision making and learning and inference give the piece of the information about the word of the game with the collected data, assume with the model of the prior over the model parameters with the make the decision about the action classifier model parameters, etc. Probability frequency Bayesian with the frequency probability to find limited infinite number to trial with the probability of the particular K1 landing heads of about up to 43,000 an inch. 43 hundredths of an inch over the bias and subject to probability quantity theory with a degree with a belief of the example of the probability raining for tomorrow at 3/10 of an inch, not possible to repeat tomorrow. Basic definition 3:1 probability sets of the sample of space of dimension show the normal regular set of numbers 1, 2, 3, 4, 5, 6, and probability is the area of the union of the space domain is in a range of 0 to 1. Probability of the given set 1 equal to 1 to 6. Probability of the 4 set would be 1 to 6, and probability 2 to 5 range. X and Y domains equal to 1, 3. Axioms of the A, B, and C unioned with the space system sample space of divine negative of the parameter of the area is greater than or equal to 0, additive of the parameter A as A and B equal parameter A but the plus parameter B with is a additive A is and A if A is I don't know what the union would probably be. It's probably not B or the associated B with the sum of the normalization parameters of the space domain is equal to 1. In one case, in 0, the parameter A is greater than or is less than or equal to 1. Parameters of the set is equal to 0. The A union equal to B is the result of the PA with the less than or equal to PB with the parameter of A to U union some type of P to A U B union PA plus PB with the PA minus B parameter of the space domain range equals over the divided by the area equals 1 minus P for the parameter area probability of random variable to X of a discrete domain X is equal to the space domain and it's quite some logarithm for the random variable X and discrete with the domain with the X. So we'd have zeros greater than or equal to P times X to equal the X variable X equal to the X coefficient greater than or equal to 1. Logarithm X based X is equal to the efficiency of the space and domain parameter X is equal to the variable X equal to 1. A dice can take as example. The dice can take a value of the number set, the parameter set in the domain 1 through 6. X is the random variable the dice throws. Parameter X is equal to 1. The range of 0 to 1. Probability X takes the values 1 bit more formally random variable maps of the measurable space of the domain sample space with thereby introduce probability measures on the domain. Probability distribution parameters X if it equals to 1 with the range of the R denotes specific probability parameter X if it donates with the probability distribution function over the space with the domain range. Example, the dice takes over the value of the domain ranges 1, 2, 3, 4, 5, and 6 with the parameter X if it describes the full distribution over the possible values of 1 through 6 of these numbers. Some of them to 1 usually stored in 1/6 is in range. Implementation and typical representation, distribution, discretion, random variables over the table, the array of the number, the notation, summing of the random variable, the equation often needs some of the random variable array, the shorthand equation number of the logarithm X if it equal to parameter X if so on, so the logarithm of the range of the domicile of the X of the parameter X is equal to X extenuated joint distribution as we have two random variables X and Y. The function definite parameter X is parameter X is equal to X and Y is equal to Y. Definition joint is a P is the range X and Y, two variable mode in the range of the range is the X and Y. The marginal parameter X is equal to logarithm Y. P is equal to X times P parameter times X times the X and Y or the parameter. Marginal is Px with the logarithm Y times the joint. The conditional of the joint equals the joint over the parameter Y. Condition is normalized if it is the logarithm of the X is equal to the joint equal to 1. The X independent of the Y is if the joint is equal to the parameter X. Thinking of the columns of the parameter of conditional are equal. Joint distribution, joint and marginal Px is equal to logarithm Y with the joint with the conditional P as over equal times X over the Y with the equals the joint over the P over Y. Implication of the definite product rule: a parameter X of the joint over the parameter of the conditional and the parameter of parameter x y over x over the times px of the Bayes theorem. Conditional is equal to parameter p times xy over the pyx of the px of the py. Bayes theorem. The conditional of the xy is first part of the conditional is equal to the partial parameter y x with the parameter x with the parameter y. Posterior is equal to likelihood times the prior normalization, modelization, random variable analogs, random variable over the ink with the tensor, and joint is equal to the parameter x1 over the in the set of in the variable n marginal parameter x1, and then issue of the x is conditional independent of the y is given to z. The product rules of Bayes' theorem, probable distributions in 3-2, binomial random variable is x is the range of the 0 to 1, and the domain of the x is equal to the range set of 0 to 1. Binomial distribution parameterized singular scalar. Parameter x is equal to 1 scalar to the scalar. Scalar is equal to square. P is x equal to 1 over the set of square. Oh fuck. We have data set of the random of the barium. We have, I don't really know how to read all these logarithms, so we'll just distribution counted, distribution m is equal to logarithm to the nth to the base of imagination I. Alright, beta. How do you express uncertainty with the Bernal parameter? Beta, distribution overall interval OX, XY range, particular parameter unit Bernal, which means the mode. Crucial point, assuming the world with the Bernal source don't have the known pattern, assuming the prior distribution equals beta. Our conclusion: semantic, the prior beta of the posterior of the beta of the semantics with A and B counts with the x and I equals 1 and x equals 0 respectively. Beta distribution conjugate Bernal expand later. With beta distribution represents belief at the table with the knowledge about uncertainties of the set of the range of the 0 to 1, knowing how to update the belief of the given data. And then it shows a different kind of for the bishop, multiply from bishop 319. Multi-nominal, we have an integral random variable x is equal to the range of the 1 through k with a probable single parameters with a parameter set of the set of u1 parameter k with constant random data set randoms. And Diuretics is how to express uncertainty in multinational and multinominal parameter diuretic distribution. K simplex is these logarithms I can't read anymore. Diuretics are conclusion semantics of the count as xi over the x. The theoretical distribution conjugate multinomial diuretic distribution represents belief in the state of knowledge about uncertain used in the random variable to know how to believe in the diuretics illustrations. And motivation better the theoretical the distributions. If the binarity integer banded for the beta of the theoretic the distribution wave of the represent of the update with the belief space with the become of the discrete with the parameter with the power continuously, but with the posterior update living with a discrete grade adding as a count over the A with the principle with the belief of the using this reinforcement learning assuming that we know the world with a finite with an MDP but do not know the transition probability for each of the problem possibility parameters of the distribution integral. They have the interpret the distributions of the state of the A with the represent of the belief of the world with the belief of the parameters of state with the state of the A. Principle with the belief of the use of the Bayesian reinforcement learning theoretical the distribution also use the model tech for the word distribution tech for the images mixture of the distribution in general. Conjugated priors assuming that you have the data with data D equal to x1 to the x to the nth likelihood parameter D. The parameter of the data is range is 0. The depends of the is divided by the parameter uncertain parameter 0 with the parameter 0 conjugated likelihood of the parameter of the data if the posterior of the parameter of 0 is greater than over the data is set it with the parameter data over 0 times the parameter of 0 data, the same as the distribution cost parameter 0 with the having conjugated power with the convenient with the you know how with the update with the belief given conjugated likelihoods, binomial bin, DDU, beta for the beta U, conjugated multinational multi-directive, and cause, Gauss, I1D class Gauss, Wishart, and it's a pretty distribution. Try to explain while reading. 3. Distribution continuous domain. Distribution over continuous domain. Let X can be random variable with a probability density function of PDF. Parameter X is the range of 0 to the infinity, but it defines a finite solution. It defines problems with a formulated probable distribution. Is cumulative integral limited with y to the infinity with the Fy equals 0 with a Gaussian and a diuretic Gaussian distribution. And let's see if it gets any other easier. Motivation, Gaussians, control bands, control theory, static optimal state. It's a little bit over my head. Wonder if entropy, callback, Lieber divergence. We're going to skip this and we're going to move on to Chapter 4. Band's MCTS, Monte Carlo tree search, and games. That should be interesting.